our viewers to another episode of Solidity Fridays with Johannes and Roman from Nerif Network. I'm joined today by Tamara, as ever, the wonderful technical host. Solidity Fridays is brought to you by Linum Labs and Web3 Sanctuary. Let's dive straight in. So perhaps we can get a little bit of an intro on Nerif Network and on Johannes and Roman.
Sure. Hey, thank you so much for having us here. My name is Johannes. I'm one of the co-founders from Nerif, head of running around, I always say. Roman is the second of our three-piece founder team. And basically what we do with Nerif is our goal is very much to make Web3 developer experience suck less. Now, how do we do that? We help you automate, the back end of your smart contracts. And I'll give you a very brief overview on that, how that works, and then we'll dive right into the smart contracts and the tech details. And we would, very happy to give you a bit of an intro and love to see some of you join or actually use and build on Nerif for their projects, and let's figure out together what you can actually make with it and what cool things you can do. So Yuval, if you could share my screen, that would be much appreciated. And I'll just give you a very brief overview of why Nerif is relevant. So
there we go.
Looking at the app, how does it typically look like? There's three parts. You have a blockchain, right, which is where you store your data typically. And on top of that, you have a set of smart contracts, which is for the actual business logic where things happen. And then on top of that, you need some kind of user interface, be it a CLI, be it a web app, be it an application, mobile application. Now, that's the theory. In reality, it looks quite a bit more like that, where to actually make your application work, you need a lot of surrounding parts. We call it the non-core components of the app, which, however, provide all the UX. This goes from things like notifications. You might want to let your users know if something on-chain happens, all the way to maintenance tasks. You might want to run cron tabs. You might want to run cron jobs. You might want to have cross interactions. You might have to bundle things up, automate transactions to make things gas efficient. You might have to integrate off-chain data, oracles, and so on and so on and so on. Now, all those parts are typically done in a somewhat centralized way, where you would run your own server, most likely on AWS, which does that for you. Now, this has a bunch of really, really big drawbacks for everyone here who's built this will know that. It's super expensive to run and especially to maintain. So not necessarily the server cost, but implementation, the complexity you have. It breaks all the time. You have to keep all those things updated. And from a security perspective, it's really, really bad, because what you will typically do is that you will actually host your private key on one of those servers in order to trigger an on-chain transaction. There's no really other way to do that in a centralized way. So yeah, so that's kind of the why Nerif was built. So Nerif has this idea of taking this all away, allowing you to build all those processes and tools without having to rely on centralized parts. Now, enough said. Let's dive in. So I'd hand over to Roman, and he will show you basically how we do that on a smart contract and the architectural level.
Amazing. Cool. Thanks so much, Johannes. So Roman, I will share your screen shortly.
Yeah, sure. So before I start, let me make a quick intro about myself. So I'm one of the co-founders of Nerif Network and CTO here, in charge of all product development things. So let me just quickly share the diagram. This is the smart contracts repository of Nerif Network, and in the README you can find the diagram of the whole architecture from the high-level perspective. So Nerif's architecture consists of three um, three parts. So the first part is on-chain logic, which is smart contract setup. The second part is off-chain logic, which is like the network of Nerif nodes or
Okay.
validators that represents Nerif network. And the third part is Nerif app. You don't see it here, but imagine some like third component, which is just regular user interface where users can interact with Nerif network, not through RPC, but from the browser, from the website, and build workflows from the website.
Amazing.
Let me,
So it
yeah,
acts a little bit like a Web3 or a smart contract Zapier in that sense, building out workflows.
like that. Actually, I can quickly share the application and
Amazing.
even show how it works and what is that. So here you can see the page of all workflows that I have within my account with different statuses. And what is the actual workflow is? So let's open the one active workflow that I have, which is called Nerif Bridge. And this workflow allows me to automatically transfer arbitrary data from linear testnet to Polygon Mumbai. The workflow itself looks like that. So it has event-based trigger. So basically, Nerf network listens for a specific event that user specifies in the trigger configuration. And then when this event happens on chain, Nerf network triggers this workflow execution. And the second step and the last step is transaction. So in the transaction step, this workflow just creates a payload of a specific function within Nerif Bridge smart contract deployed on Polygon Mumbai and passes payload from the event-based trigger. So this is how you can easily create your own data bridge from one chain to another with Nerif network.
That's awesome.
Yes, and yeah, let me go back to the diagram again. And in this diagram, this one. Okay, let's have this one. So here you can see the Nerif app that I mentioned before. And basically, this is the application that I showed you.
Perhaps you could just zoom into the relevant parts as we speak about them, if possible, Roman.
Yeah, of course. So
that would be amazing. Perfect. Thank you.
Let's discuss the on-chain setup, on-chain logic first. We have sidechain and main chain. The difference between sidechain and main chain is that our system contracts, the blue ones, are deployed only on the main chain. Other chains that we support have just the same contracts, such as registry and gateway. The main chain has system contracts, which are blue. And those system contracts represent some very important parts needed for security purposes and also token management and validator rewards. So let's start with the security part, which is the most interesting part in our architecture, in my opinion. So yeah. One second, let me share another screen. Sorry. This one.
Great.
In order to make the Nerf network secure in a decentralized way, we end up with a cool solution, which is called DKG, distributed key generation. This is the procedure of creating a common secret shares across all validators within the network in a decentralized way. So during DKG process, all validators of the network exchanging special secret artifacts for 6 rounds. Like each round, each validator generates specific random data, like very, very huge data, and shares this data with other validators. And each validator does the same. And after 6 rounds, each validator has some secret artifact generated during DKG, and this is the result of DKG. Each validator has specific secret artifact, as well as shared public address, just like Ethereum address.
Okay. Amazing. This is a really deep and interesting conceptual part of what you guys are building, I think. So I would love to dive in a little bit deeper on this. How do all of the validators communicate with one another? Is it similar to like the Bitcoin Gossip protocol, or do you have a cryptographic secret sharing technique?
Yep. So we have two different approaches that we use in different situations. So when the network starts up and the validator starts DKG process, they use DKG contract in order to exchange this data. So they are not connected to each other. They like start DKG process and submit the secret artifacts to DKG contract on each round. Each validator does the same. And each validator gets secret artifacts from other validators by calling specific function in this DKG contract. So those validators are not connected to each other during DKG. But once DKG is completed, validator starts peer-to-peer networking between each other, and they start to serve workflows that I just mentioned, that I show in the Nerif app, in the website.
Amazing.
So yes, and also very important part is that this DKG process is dynamic, and the network starts DKG like every 5 minutes in order to generate secret artifacts again and again, just in case if some of those artifacts get stolen or something else happens. And also they start DKG round when a new validator joins or an existing validator leaves the network.
Great. I think that's a really interesting idea to dive a little deeper into. So let's perhaps move on where you think would be a relevant next step from there.
Yeah, next step is to just understand that this process is completely off-chain and very, very cheap and secure. By cheap, I mean that after DKG round, the network of validators have a shared address, shared Ethereum address, let's say. And the network can send any transaction from this address only when a specific number of validators, majority of all validators, signs the data. So for example, if I want to send transaction from the collective address generated by DKG, I have to get signatures from 3 or 4 validators of the network, like from the majority. And once those validators, one majority of the validators signs the transaction, we can send it from by the collective address. And the registry contract just literally does nothing and can be 100% sure that the transaction is valid if the sender of this transaction is the collective address.
Okay. We love a contract that does nothing.
Yeah, it just does nothing. If I get transaction from 1 to 3, it's secure and valid. And
I mean,
I know
you can
100%.
maybe Roman, you want to quickly show that in the code actually how it looks like in real life. How this is implemented.
Yes, that would be great.
It's actually a code, right?
So
let's dive into the registry contract.
Registry contract. So the registry contract is not that interesting. It just okay.
So that will contain a list of all of the relevant Ethereum EOAs.
No.
Okay.
No.
So it is
I
interesting.
don't understand. Hey Siri.
My Siri is playing up now. Siri is also curious about our contracts here.
Registry. So in the registry contract, we have one important function which called perform. So remember that workflow with bridge that I show you in the Nerif app? We have transaction there, and this transaction is executed by Nerif network, and this transaction goes to the registry contract first, and then
Okay.
from the registry contract it goes to the customer contract. And on the registry step, we have to, like, the registry has to make sure, checks that the incoming transaction is secure, valid, and can be executed. So here we have one modificator which called only signer, and this modificator basically checks who is the sender of incoming transaction, and if the sender of incoming transaction is collective address, we assume that this transaction is secure and really sent by Nerif network. So we don't need to store any information about validators, just nothing, only collective address, and that's it. And these security checks just cost, I don't know, almost zero, very cheap, and this is very cool.
Okay. Amazing.
So here it
So
just
basically,
checks.
how it works is whenever DKG is run, a new sender address is defined, right, which is the shared address. And then this contract can be sure that if it is signed by this signer address, it is basically the approved multi-sig.
Great.
So
Okay,
that's where
understood.
the DKJ part comes in, right? But that's actually where the interesting thing happens, where this signer address is being created, which isn't just being stored on chain as one address, which is not a real address in a sense. It's this abstracted away multi-sig, if you will.
It's like the whole group of nodes.
Yeah, and this multi-sig, as you want, is done by threshold ECDSA. So we have DKG, which is the process of generating secret artifacts shared across all validators and collective address. And then we have a threshold ECDSA approach to get signatures from all validators and then create a aggregated signature that will be broadcasted to the blockchain. And this collective signature will identify the sender of this transaction, which is collective address. So it's like two security thing is DKG and threshold is CDSA. So coming back to the registry contract, apart from this very small modificator that checks who is the sender of the transaction, nothing really specific here. So we just check the user balance. If the user has enough funds in order to execute this transaction. We also calculate how much this transaction will cost and just update the balance and then emit the event that this transaction, this action was executed. Yep, so in terms of the registry contract, this is the most interesting part. Apart from this, you can find some management functions to like pause and activate workflows, add and withdraw funds, register new workflow, and so on. So if you guys want me to deep dive to some specific part within this smart contract, let me know.
Perhaps, are you able to zoom in your screen a little bit more? It seems some of our viewers are having trouble seeing the code.
Like that?
That's fantastic. That's so perfect. Thank you.
Cool.
Maybe Roman, Tamara, Johannes, if you are all right with this idea, perhaps we can walk it back a little bit and take a look at the structure of the repo and how you guys have structured your different contracts so that we understand from an architectural level how exactly you're building out this product from the ground up.
Yep. So in terms of the contracts, this is the network, this is the contract.
Yeah.
The blue contracts is the system contract. So system contracts are needed to make the Nerif network work. So this is nothing related to end users. And there is operational contracts, which is registry contract and gateway contract. Operational contracts needed to make the actual workflows work. So basically, when if you have a workflow and your workflow contains a transaction inside, and when the time comes to execute this transaction, Nerif network goes through all the security things through threshold CDSA part and so on and so forth, prepare transaction, and then it sends the transaction to registry contract. Registry contract checks that this transaction is really sent by collective address, and the collective address is stored in the DKG contract. So registry gets it from DKG and checks that the sender of this transaction is equal to the collective address. Then it goes through all these checks related to balance and so on and so forth. And if everything is okay with the given transaction, it passes this transaction to gateway. Gateway contract belongs to the customer, to the user, to the owner of the workflow. And the gateway just simply checks that the given transaction is coming from Nerif network, and this transaction is part of specific workflow that belongs to the specific user. Also, some kind of security and validity checks of the given transaction. And if everything is okay here, the final transaction goes to the customer contract, and the customer contract gets executed. This is the flow of transaction step within the workflow. Apart from this, there is DKG side that I explained, and also we have staking mechanism. We have staking contract. So basically, this contract is needed to stake specific amount of tokens that allows new validators to join the network. So as a new validator, I have to stake tokens. I will get approval from the network in order to join, and then I spin up my node, Nerif node, and the network starts new DKG round with my validator. A new collective address gets submitted to the DKG contract, and a new validator becomes active. Similar happens when something goes wrong with existing validator, so it gets slashed. So network just removes validator from the off-chain network, and staked amount of tokens of this validator gets distributed across all validators, all active validators. So we don't return it right now.
Fantastic. Perhaps we could dive into the code for the DKG a little bit more. I think that's a really interesting contract.
Sure.
Great.
So DKG. What we have in DKG. In DKG contract has the concept of running DKG round is represented as a list of generations. Each generation is a new iteration of the DKG process. So when the network starts up, a new generation gets created, and the DKG round is started. When a new validator joins, new generation gets created, and the DKG round started. So update generation, basically, yes. For example, when a new validator joins the network, the DKG contract executes the update generation function, and this function just updates the local storage of the generation info. Depends on the number of validators within the network that we have at the moment. So if it sees the new validator join the network, it just updates the generation list, and the network catches a specific event from here and starts new DKG round. What else here is interesting? So basically, yeah, this contract just represents a very simple local storage of of DKG artifacts as well as generations. And also this contract contains the collective address of the network.
Okay,
So
cool.
it's also quite simple. So if yes, if you have specific question, I can deep dive into it.
Yes, absolutely. I'd love to hear a little bit more about the architecture of the collective address. If you set that up like a Gnosis safe multisig, or if it's a more standard smart contract wallet, perhaps you can tell us a bit about how you've structured that in the code.
Well, I don't know if it would be either because it's the DKG. Isn't that done through your back end, and then they all route to the collective address?
Yes, correct. So DKG process is done completely off chain, and the DKG contract just contains these secret artifacts that these nodes exchange during DKG round, and then when it's finished, it just updates the collective address, and that's it. This logic is also very simple.
Okay, cool.
On
What
top of
language
it,
did you do that all in?
for the off-chain side,
Mm.
yeah. So for the off-chain, for like we have Golang as a primary language
Okay,
for
that's
all
cool.
backend things,
Mm.
and yeah, Solidity for smart contracts.
Okay, that's a
So
good combo.
yeah, so the idea of moving all this DKG process to the off-chain was that having it off-chain might be very expensive because these DKG artifacts are very huge, and if we have to submit them every time to the blockchain, to smart contract, it might cost a lot of money, especially on Ethereum. So I remember I was trying to make it done on chain completely, and one transaction, one DKG round cost me around 10 or 15 Ethereums. So
Wow, that's
yeah,
Wow.
crazy.
it was just we had to move it off chain. With
Okay.
some on chain helpers.
Right. And then a big part of the network and the node architecture is how you ensure that that's still verifiable, all your off-chain computation.
Yes, correct. So even though we can move whole DKG process to off chain and remove this DKG contract completely, it might work just well. But we keep it for now because we have staking and slashing processes. So if new validators wants to join to the network, they have to stake specific amount, and we need to somehow catch it on chain and then start DKG process off chain.
I
But
see.
without these things, we even don't need any smart contracts for DKG things.
Right. And what are your users staking specifically? Is it Ether? Is it your own token?
So currently we don't. It's not required to stake specific number of tokens in order to join the network because the tokenomics part and these DAO things is not really completed at the moment.
Okay.
Jonas can share more information about that. So in the future, probably we will use our token as a staking token. Yeah.
Amazing. So you do have your own native token on the roadmap for future.
It's not native. It's ERC20 token on, I don't know, Ethereum, Polygon, any chains.
I
Yes, we
think
have it
this
on
is one
our.
of those things which are still being, in discussion, in development, how to most efficiently make this happen, because we're, in the end, our biggest interest here is to have a system which is as stable as possible. And there's very different
Absolutely.
approaches on how to do that, with keeping this idea, or not this idea, but the need of it being provably decentralized and basically independent of any essentially controlling party, which is, in the end, at the base of it, being able to be used to secure $1 billion transactions, right? Where you can be sure, okay,
Yes.
You really only rely on the tech and on the publicly documented and available tokenomics, however those might look like.
Right. Okay, that makes perfect sense. And I think that might be a great segue for us to understand the customer side. I think ultimately this is a really great use case driven product. So perhaps we can dive into the gateway contract and some of the other consumer or user facing parts of the architecture. Roman, I think we lost your audio there.
Yeah, sorry.
No worries.
So
There we go.
you can share this DKG contract in the chat. So if anyone wants to deep dive into it and see
Amazing.
what's
So
going on there.
I shared the repo in chat. I'll repost it again. I think it's such a well architected code base, and more people should check it out for sure.
Sure. So gateway contract is belongs to end users, and we offer a feature on our UI that allows users to just deploy this gateway contract and link it to the registry within a few clicks. Or users can deploy this gateway by themselves and then link this gateway contract to our registry. So registry knows what gateway has a specific user. It's like one-to-one mapping between
Okay.
between address and gateway contract address. So here we have a code where so as I mentioned, gateway contract is created to make sure that the given transaction is coming from specific workflow that belongs to a specific user. So it's kind of second iteration of security checks that is done on the user side. So the Nerif network has some security checks on the registry side and then passes this transaction to user, and then user has to also do some security checks in order to make sure this transaction is not malicious, and that's why we have gateway contract. So also very simple one, we have perform function here, and this function accepts 3 arguments. The first one is ID of the workflow.
Okay.
The second argument is the target address, basically the customer contract address. In case of this breach workflow, it's Nerif breach contract address.
Okay.
And then the last argument is payload. Basically, this is the call data that should be executed on customer contract level. So we have these 3 arguments, and then we have just 2 modificators. First one, modificator checks that the given transaction is coming from the registry contract. And the registry contract belongs to the Nerif network. So this is the first security check. The second security check is to make sure that this transaction is part of a specific workflow. So only allowed workflow modificator has workflow ID and target. So here we get the workflow from the registry by the workflow ID. Then we check that the given gateway contract owner is the same as a workflow owner. And we allow this transaction if it is, or if this transaction is part of any other workflows that are whitelisted or blacklisted.
Understood.
Cool. So you could do other people's workflows.
Yes. For example, if I know my friend, and my friend has a specific workflow, and I want to accept transactions from this workflow, I can whitelist this workflow as well.
That's cool.
So what else we have? Reward distribution pool, also very interesting contract.
Let's dive in.
Yeah. So what is reward? Reward is the like specific number of coins that validators receive every time when they execute a workflow, right? So users have to cover the actual operational cost. In case of transaction is the transaction cost, and also they have to pay small, not like defined percentage of fees that goes to the Nerif network, that goes to the validator. But before they go to the actual validators, they spend some time within the reward distribution pool. So every time when the Nerf network executes the workflow, it takes some specific commission and puts this commission to the reward distribution pool. And once like when the validator wants to withdraw its rewards, it goes to the reward distribution pool and sends transaction to claim rewards function. And this function basically calculates the amount of rewards for the given validator and just sends those rewards to the validator address. Yeah, so this is how it works. Currently, we support only native tokens within the reward distribution pool, but in the future we will implement support of ERC20 token, and it will be our token.
Okay.
And this token will be used as a for rewards, basically.
I think maybe A16Z was calling you to find out how they can invest.
For sure.
Super exciting. So I would love to hear maybe at a high level what sort of use cases you guys have been building out internally, as well as what use cases you've seen some of your early beta testers or friends or family building out, and how you'd like to see users building on top of Nerif for now.
Johannes, I pass it to you.
Let's get your audio going there, Johannes. Are you?
Sorry, I lost you there for a
Perfect.
second.
Sure, no worries. Of course. Is my audio good on my side?
No, it's good again.
Fine and clear. Great. So I was just asking, I'd love to hear at a high level what sort of use cases your current beta testers or friends that have been testing out the platform have been building out, what you've been focused on building out internally, what you're excited about, and then maybe how users can begin building on top of Nerif and what you'd like to see being built.
Sure. So there's two parts to it, right? There's like the quick wins and the more deeply ingrown stuff. And on the quick win side, what we see people actually using it quite often for is just notifications, because this is super easy to set up. Doing an on-chain event to let's say a Discord notification takes about 5 minutes to set up max for the first notification, and then subsequent are a lot quicker because you've already have your Discord API key you need to do it. So that is kind of what we see many people just trying out and kind of using it for whatever purpose they might need. It might be they're interested in seeing what is happening on Lens, or they're interested in certain smart contracts. For example, we had one example looking at short addresses registered on ENS, like very, very specific stuff.
Right.
And then the other thing which we're seeing used quite often already is kind of the moving some kind of off-chain calculation partially on-chain. Typically, that might be rewards distribution, right? Rewards calculation, where you build a DApp, and whenever you do a transaction, you earn a little reward, which accrues, but you can only withdraw it on a certain kind of time, for example. So here they would trigger an event, do kind of this calculation off-chain, make some validity checks, make some spam checks, and then actually accrue that thing on-chain, right? So that's where you have this full thing. You trigger something, you do an off-chain or like calculation on Nerif, and then you put it back on-chain and make it gas efficient because you can batch up those things. Well, that's
Okay.
that's like the first, obviously there's so many different applications where there's a lot of kind of things which have been done once, but those two things are things which we've seen repeatedly being done. But we're kind of in quite early beta testing, so there's whoever we talk to has a different kind of idea how to use it. For example, just
Right.
yesterday I had a conversation with a project. They need to connect two different smart contracts. Basically, it's a game, and they need to see, okay, well, is this person who's done that contract, has this person is already been interacting with a different smart contract, and if so, they would accrue something, or they would get a special token. All those reward systems, which is just a lot easier to implement using Nerif than using a different way of doing so. Cross-chain even, right? You can say, okay, I want to see this person that has done something on one chain. Is this person also been active on another chain? If so, well, on a third chain, we'll give them a token, maybe.
Okay. So
Now,
there's potential for like airdrop
for example,
analytics for DAOs,
example,
or
exactly.
If you want to implement cross-chain voting. So let's say I have a token on Ethereum mainnet and on Arbitrum, and I'd like to understand people's cumulative balance on both chains, things of
Exactly.
that nature.
Or
Amazing.
even making gas efficient, right? You have your contracts
Yeah.
on one chain, but you want to do the voting on a very cheap chain, and then based on that
Without
voting,
bridging.
Exactly.
That's really
Also,
cool.
Exciting.
very cool use case when users when actual DAO members votes for specific changes within the code, and when a specific threshold of those votes got submitted to the blockchain, we automatically trigger the GitHub pipeline to do some deployment things or whatever.
Wow, that's cool.
And that very much also shows in the direction we're going. So, right, so Nerif is built, now it automates stuff, but we're building towards orchestration in a sense that you should be able to handle the whole kind of end-to-end pipeline of your DApp development, from smart contract deployment, CI/CD, front-end deployment. So there's really cool tools now out, or not tools, but projects out there where you can actually you host, you don't have to have AWS anywhere. In the end, you don't really care where your front end is hosted, as long as it's secure and scalable, right? So
Right.
what Nerif allows you to do there is basically to trigger even that from front-end deployment. So you can connect a DAO to a front-end update. And
Wow, that's awesome.
the big beauty is that the whole payment is also on Nerif. Because we anyways implemented kind of this whole payment, prepaid in a feature which we need to pay our gas fees. So if you can, anything you can basically pay on chain, you can directly bill via Nerif automatically, and then because of the automation you allow, you can either pay it yourself, or you say you automatically connect it to your DAO treasury, or you charge it to your user. Right? It makes it completely programmable, and you don't have to have different accounts anymore. You don't have to have a credit card to pay your AWS services. It's just kind of in one place, completely orchestrated by Nerif, managing the whole back end of things.
That's so cool. And creating a workflow seems really simple on the UI. We've made it really easy to do.
Yeah, and the workflow also might have not only on-chain interactions, but also JavaScript function, webhooks, I don't know, notifications, whatever. This part that we just saw on the architecture is that which is related to on-chain interactions only.
It's really cool that you can do on-chain and off-chain interactions. I think a use case I'm really excited about is liquidation bots.
Liquidation bots, and also price oracles. You can build a workflow that gets the price from different sources, and then create JavaScript function within this workflow that does a average of those prices, and then submits transaction to price oracle smart contract.
Interesting. So in some sense, it's a bit like a DeFi meta primitive, right? Like you're stitching together a bunch of different primitives and allowing that overarching pattern to be built on chain.
Yes, but we try to avoid the term DeFi a bit. And the reason is very simple, that our thesis here is that Nerif is built for the post-DeFi world. And what do we mean by that is that what makes DeFi or like successful is actually the restrictions that the technology had. In a sense, you had very high cost per
Right.
transaction and very low throughputs. So in DeFi, typically each transaction has a very high value, but there's very few stuff on chain. The majority of the things happening in DeFi is off chain. Now, what we see is happening is we're moving towards this world which is called the volume-driven world, where you suddenly have a lot more things on chain. But each transaction individually is smaller, has a smaller value. But because there's a lot more, the volume in total of transactions is a lot bigger. Examples here is SocialFi, GameFi, all that kind of stuff, which is being enabled now by, let's say, the new generations of layer 2s and layer 1s. We're quite close to Polygon, so that's where we really see a lot of this new use cases happen. And those use cases, they need a lot more of this because they're a lot more decentralized in a sense. DeFi is already decentralized. It's just like a small part is decentralized. Because they need a lot more automation as well. And UX becomes a lot more important because it comes to this idea of onboarding the next 1 billion users, which, or the Web3 community is kind of carrying around. And we're building the backbone for that.
That's
Exciting.
so cool. Do you know Turbo for making monorepos? So like there's this thing called Turbo, and you can automate like workflows within just like a monorepo. I almost think of you as a decentralized Turbo.
What is a monorepo? Maybe question 1 for me.
So it's like the front end and the back end and the smart contracts all kept in the same GitHub repo. And then I can say turbo run or turbo dev, and it deploys my smart contracts. And then it's after it deploys, it builds the indexer, and then the indexer looks at the smart contracts, and that builds the back end and the front end.
Okay. So one second, let me quickly answer that question from a yes. You will get a referral code just now. Please do not sign up without the referral code. Wait until you have it, because otherwise you'll end up in a waitlist, and we'll have to approve you. So let me quickly, actually, while Roman talks, I'll create a custom referral code for you guys. And you
one
talk
of the
about
most
Turbo.
One of the most efficient teams in the game.
That's really
thank
exciting.
you so much.
So yeah, but basically back to you, Roman, regarding the Turbo question.
Turbo question. I didn't look at this project yet, but from what you are saying, what the purpose of having blockchain and like the on-chain side of things within this Turbo thing, Turbo, whatever.
What's the point of having it as a monorepo?
What the point of having the blockchain there and on-chain interactions? Like, so you mentioned that they execute a deployment when something happens on-chain.
No, it's just when I go into my monorepo and I type turbo dev, it deploys my smart contracts once and then builds everything out of it. Or you can have it not build the smart contracts and then just rebuild everything that like the indexer and the back end and the front end around it.
Okay, got it. Yeah, so this is one of the cool use cases, and I think this is something similar to that one related to DAO and votes that I mentioned some time ago. Yeah. So Jonas.
I am still starting up my stuff. Unfortunately, database GUIs are somewhat slow. One second, bear with me. Keep talking. I go.
So I would love to hear a little bit more about the future of Nerif from 2 fronts. What would you like to see built? Are there any exciting things that you're not quite sure how to architect and you think users might be able to come up with? And also, what is the future of the project from the perspective of roadmap, investment, when token, when whitelist, all the good stuff?
So whitelist comes now.
Whitelist comes now. Tokens.
We love to hear it.
I just sent you the referral code I just set up.
Amazing. I'll be sharing that with our viewers shortly. Thank you for
Very
looking
nice.
after our viewers.
So we're currently in the process of closing a seed round with the goal, the thing is live, you can use it to go to market, to build it out. A very critical step will obviously be the decentralization process, as mainnet alpha is currently kind of run, the nodes are run by Nerif itself. So the first step there will be that we'll be working on onboarding kind of a set of known node runners, big node runners, and then take it from there, right? Build it out from there. And with the end goal, obviously, of opening up and making it completely permissionless, so anyone can run a node on the Nerif network. When token? Not going to answer that question.
Right.
Maybe token, maybe no token. Who knows? And yeah, I mean, what really we're excited about right now is build on Nerif, try it out, give us feedback. Let us know what works. Let us know what you need to make it work for your own application. Let us know what kind of workflows or kind of business use cases you guys are thinking about. Because that's what I'm really excited about, right? It goes back into, I don't have my cap here, but in a sense, let's make Web3 suck less. Let's build a really, really cool Web3 world where we don't have to hide from a UX perspective behind the Web2 world, which has been doing that for the last 20 years or so, becoming good at it. I mean, that's great. Oh yeah, also we do tacos, but maybe the guys.
Huge value add. That
I always have to mention it, right?
you have to. People are out here talking about digital phygital. I think the real phygital utility is people meeting IRL for good food and having good conversation, right?
Exactly. So we have this community where we bring builders together in real world at conferences. We will be in Lisbon after ETH Global. Sorry, not ETH Global. After ETH Lisbon, so the 5th of November, we'll have a one, and then we'll also be in Istanbul at DevConnect. So if you're either going to be in Lisbon in November or in Istanbul, should hit us up and we'll share a taco and talk about how to make Web3 suck less.
Can highly recommend these events. I've been to two in two very different parts of the world now, and it really does attract some of the brightest minds. Since we have a couple minutes left, I'd love to get your thoughts. Maybe we can try something interesting. Would you guys feel comfortable building another quick workflow on the fly from an idea that you've maybe not built out before?
Sure.
In the next 5 minutes?
Well, Roman, are you up for the challenge? Or actually break stuff? What do you want to do, Yuval? What are you throwing at us here?
Well, of course, we can do
that. Tamara, do you have any ideas off the top of your head for a 5-minute workflow?
For a 5-minute workflow, yeah.
I'm putting you on the spot here.
I have an idea how we can build the workflow of the lottery process. So basically, there is a simple contract with the lottery where users can just send funds to this contract. And then once in a time, we need to check if there are some players. And if there are, we have to send transaction. And this transaction will execute specific function to pick up the winner.
So just to be clear, which address should users send funds to now?
You will see.
Yes, you will see. Actually,
send ETH to Ben.
Oh yeah, we could play that game together. It would be quite fun. Let's do that, Roman. Which network are you gonna build it on?
But wait, I don't remember the lottery contract address. Let me just double check in my.
I mean, if we have something on Polygon, that'd be really cool.
Yes.
Not on.
Oh yes, I have the lottery contract. So I share the contract in the chat. And now I go to the workflow, and here is my draft lottery contract, lottery workflow. So I put the workflow name. Now I have to choose the trigger, execution trigger. In our case, I'll choose the cron rule, which is time-based trigger, because I want to execute this workflow like every minute. And every minute we will check if there are any players or no. Like ideally it would be like once in a week or once in a day, but just for the demo purposes, we do every minute. So here we have trigger. I put 1 minute here. And then the first step is to check is to execute specific function in the lottery contract that checks if there are some players or no. So I use if call here. This is the free operation. And in this if call, I choose Polygon Mumbai. And then I choose lottery contract. This is the contract that I just sent you guys. And then in this contract, I have players exist function, and this function returns Boolean variable which called exist. And we'll refer.
So a comment here. In this idea of good UX, we basically just pull the ABI automatically. So you don't really have to think about it. You plop in your contract address and it pulls the whole ABI, so you can just drag and drop, and it just makes development a lot easier.
Yep. So if you use a new contract that you didn't use in your account of Nerif before, so you just copy paste it here, and the ABI will be fetched automatically from IPFS.
And by the way,
That's an
everyone
awesome quality
who's
of life
viewing,
feature.
who has some tokens on Polygon Mumbai, we should actually deploy that stuff on Polygon mainnet, Roman. Is very much invited to play along here, right? They can participate in the lottery. So get yourself some Polygon Mumbai test tokens.
I will
faucet while you can, and we'll just share the link to the contract shortly, so you can actually participate in that lottery for now. Let's see if it works.
let me build the workflow first. So here, if call, we check if there are any players. Then the next step, basically this condition, it takes the reference to the previous if call, to the return value which called exist, and make sure that this is true, which means players exist. And if this condition is met, if this condition is not met, meaning there are no players, we just exit. Otherwise, we send a transaction to the same lottery contract, and then we can also send a webhook to, I don't know, to some third-party service, or you can send email notification to.
Do you have a Discord webhook API ready, Roman? If
no,
so, no. Okay, then we leave it. We don't, 5 minutes, right?
Yes, so I'm trying to finish this as quickly as possible.
Amazing. We are coming up against time, but you're doing great under pressure.
I put exit here. In transaction, I choose basically the same contract, Polygon Mumbai, lottery, and I put some gas limit. Should be enough, 300,000. And I choose pick winner function. Basically, this function chooses the random winner and transfer the jackpot to the winner. And now our workflow is valid and ready to be published. I click publish. Now I see my MetaMask notification. Not sure if you can see it, guys.
Yes. Your destiny is now in MetaMask's hands. I love that. That's a great little UI addition.
So waiting for a transaction to be mined and confirmed. Cool. Go to workflows. It's still pending.
There we go.
Spend some time, to get it.
So in the interest of our time, I think our users and our viewers now see very clearly what this platform is capable of. I think we all trust that can confirm soon. And I think we'll have to wrap up there, but this has been an amazing session. Perhaps we can have a follow-up to dive deeper when you guys have built out further functionality, and if token, then token contracts soon. So I have shown on screen the referral link. Thank you again, Johannes, Roman, for joining us. And thank you for sharing this referral link with our users. It's not very often we have something that's so powerful and so readily available for use. Just wanted to thank all of our viewers as well for hopping on. Thank you, Tamara, as well as ever. And thank you to our sponsors, Linum Labs, a best-in-class Web3 development agency, and Web3 Sanctuary, a top-notch Web3 developer education platform, bringing the next wave of devs on board into Web3. Thanks again, guys. Take care.
Thank you so much for having us.
Thank you.
Of course.
And see you around soon. Are you coming to Europe, guys?
Maybe.
You have 1 week left, literally.
Great.
See you around.
Last minute plans. Take care, everyone.
Bye-bye.